Hi students, I am Prashant B. Chandran, Assistant Professor, Automobile Engineering Department, SN80 Adur. Today, I am going to teach you about a problem on radiation, that is heat exchange between black bodies. Okay, problem number 1. Let us start the problem. Two black discs of 1 meter diameter are kept 1 meter apart facing each other. Their temperatures are 500 degrees centigrade and 300 degrees centigrade. Determine heat exchange by radiation. This is the problem. That is, two black discs of 1 meter dia are kept 1 meter apart facing each other. Their temperatures are 500 degree and 300 degree. Determine the heat exchange by radiation. Okay. It is given that the two black discs are there. Their diameter is 1 meter and they are separated by 1 meter, and their temperatures T1 and T2 are given as 500 degree and 300 degree centigrade respectively. We have to find out the heat exchange by radiation. First, given data. First, it is given that the two black discs are there and their diameter is equal to 1 meter, and the distance of separation is also equal to 1 meter. Their temperatures T1 is equal to 500 degree. We have to change it into Kelvin, that is 500 plus 273, that is 773 Kelvin, and T2 is equal to 300 degree plus 273, which is equal to 573 Kelvin, and these are the data given. Then to find, we have to find out heat exchange by radiation, that is Q12. Heat exchange by radiation, that is Q12. Okay. First of all, draw the diagram. That is, there are two black discs, disc 1 and disc 2. They are separated by a distance of 1 meter apart. Let EB1 be the emissive power of the first disc and EB2 be the emissive power of the second disc, and the resistance R is given by R is equal to 1 divided by A1 F12. Here A1 is the area and F12 is the shape factor. Okay, let us start the problem. It is from HMT data book, page number 91. Refer the graph. Okay, a graph is given. The x-axis is equal to diameter divided by separation. Here diameter is 1 and separation is also 1. That is 1 by 1 is equal to 1. We get 1, and the graph 1. That is the curve 1. The graph 1 for direct radiation. We get F12 is equal to 0.18. We get F12 is equal to 0.18 from the graph. Next, we have to find out area. In the area is A1 is equal to circular disc, therefore area is equal to pi by 4 d square. Diameter is given as 1, therefore pi by 4 into 1 square, which is equal to A12 is equal to 0.78539 meter square, which is the area. Then resistance R is equal to, you know that R is equal to 1 by A1 F12. Both the area and shape factor values are known. Substitute them. we get R is equal to 7.0736 per meter square. Unit for area resistance R is per meter square. Then you have to find out EB1 minus EB2. We know that EB1 is equal to sigma T1 raised to 4 and EB2 is equal to sigma T2 raised to 4. Therefore, it can be written as sigma into T1 raised to 4 minus T2 raised to 4. Sigma value is 5.67 raised to minus 8. The value is given in our data book. Substituting the values for T1 and T2, we get EB1 minus EB2 is equal to 14133.234 watt per meter square. Okay, this is the value for EB1 minus EB2. Then Q12 is equal to EB1 minus EB2 divided by R. Or the values are known, that is 14133.234 divided by R value is 7.0736. Thus we get Q12 is equal to 1998.01 watts. Okay, this is the answer. Thank you for watching this video. Have a nice day.